This time we're going to discuss how to apply or use the structure stack in solving the problem to determine if an arithmetic expression with parentheses is valid or invalid. The algorithm here makes use of one stack S, and it scans the input arithmetic expression string character by character or symbol by symbol from leftmost symbol to rightmost symbol. We use a while loop in scanning the input string, and in every iteration of the loop, okay, this is the body of the while loop. In every iteration of the loop, we get one symbol and we check that symbol if it is a left parenthesis or if it is a right parenthesis symbol. If it is a left parenthesis symbol, then we simply push that symbol, the left parenthesis symbol, into the stack. But if it is a right parenthesis symbol, we simply perform the operation pop. And take note that if S is empty and then we are attempting to pop from an empty stack, this would result to a runtime error or an exception when the stack is empty. This means that there are more right parenthesis symbols in the arithmetic expression than left parenthesis symbols. Now, if this runtime error or exception do not occur, then when the while loop is over, we then check if the stack S is empty, because if it is empty, then the arithmetic expression is valid. This means that the arithmetic expression has balanced parentheses, which means that the number of left parentheses is equal to the number of right parentheses. But if it is not empty, if there are some symbols, left parentheses symbols left inside the stack, that means there are more left parentheses than right parentheses, which means that the arithmetic expression is invalid. The first case here, when there is a runtime error that would occur or exception due to attempting to pop from an empty stack, this is the case when the parenthesis count is less than 0 or the parenthesis count is negative. And this second case here is the case when the parenthesis count is 0, which means that the arithmetic expression is valid. And the third case is when the parenthesis count is greater 0. So the first case is this one, the second case, and the third case. Let's recall our three examples, starting with the first one. Last time, we have this as our first example, this arithmetic expression here. Say, if we consider this as the input string to this algorithm, then as we scan it left to right, symbol on the first iteration has what value? It is open parentheses, right? This one, the first symbol. And then we check if it is left parentheses, which is true. So we push it into the stack. Say this is our stack S. So we push it into the stack. We have here one symbol, one element inside the stack. Then after that, we get the next symbol, which is X. Since it's not a left parenthesis or a right parenthesis, we do nothing. So we only perform some action, the push if the symbol is left parenthesis, and we perform pop operation if it is a right parenthesis symbol. So other than that, the algorithm doesn't do anything every iteration. So nothing is done here. This one also. When we reach this, the symbol now is right parenthesis. So it's a right parenthesis. So this is false. And this is true. So we pop from the stack. So the stack becomes empty. And then next symbol is not a parenthesis. Next symbol is a left parenthesis. So this is true. And so we push the symbol into the stack. So we have here left parenthesis symbol inside. Next symbol is we do nothing, nothing. We do nothing, and then the rightmost symbol is a right parenthesis. So this is false here, while this is true. So we pop from the stack. So this is removed. After that, we reach the end of the input string, and so the while loop terminates. And we jump to execute this one. We check if the stack is empty, and it is empty, so the algorithm outputs that the arithmetic expression is valid. So the output of the algorithm here is that the expression is valid. So the first example that we have discussed earlier is the case for this one, when the parenthesis count is equal to 0, or the arithmetic expression has balanced parentheses, and that is indicated by an empty stack at the end of scanning the input arithmetic expression string. For the second example, this is our second example last time, so let's make use of that. So let's go over the algorithm again and check if this is valid or invalid. So once again, we scan the arithmetic expression left to right. The first symbol on the first iteration is a left parenthesis, so this is true. And so we push it into the stack. Say this is our stack S. We push it into the stack. We have our left parenthesis inside. And then we get the next symbol, which is another left parenthesis. And so this is true again for the second time, and we push that symbol. So there are now two left parentheses inside the stack S. Next is A, we do nothing, minus, we do nothing, B, we do nothing. When we reach this one, the symbol now is a right parenthesis. So this condition here is false, and the next is true. So we pop from the stack. So the top element, left parenthesis, is removed. Then we get the next symbol. We do nothing for this. Next symbol is left parenthesis. So this is left parenthesis. And so this is true. And so we push it into the stack. So now we have two left parentheses. We get the next symbol, C. We do nothing for C. For plus, we do nothing. For D, we do nothing. And then we reach this one. The symbol here is right parenthesis. So what we do, this condition is false. And so we go here, we check this one. This is true. So we pop from the stack. So this top element here is removed. And we get the next symbol, which is multiplication operation. And we do nothing. Then the next, it's operand E, we do nothing, and then we reach the end of the input string. So the while loop is over, and we jump to this portion here. We check the stack if it is empty, and it is not empty. So this is false, and so the output of the algorithm is this. Output that the arithmetic expression, which is this one, is invalid. And that is the case when the parenthesis count is greater 0, which means that there are more left parentheses than right parentheses found in the arithmetic expression. As you can see in this inside the stack, there is one left parenthesis left. So there are 3 left parentheses, 1, 2, and 3, while right parentheses there are 1 and 2. So this is 2. It's not balanced. The third left parenthesis that is left inside the stack, it's not popped out because it has no pair right parentheses. So the output of the algorithm here is that the arithmetic expression is invalid. The third example that we used last time is this one. And let's go over the algorithm again for this third example and determine if it is valid or invalid using the algorithm. The leftmost character is X, so we do nothing. And the next is this division, and the third is left parenthesis. So this time, the symbol we get is a left parenthesis symbol. And so this is true, so we push that into the stack. Say if this is our stack S, we have here left parenthesis. And then next, for Y we do nothing, for plus we do nothing, for Z we do nothing. Here we have a right parenthesis, so the symbol now is right parenthesis. So this is false and this is true, so we pop from the stack. This one is removed. Next is another right parenthesis. So this is false and this is true, so we pop again from the stack. But as you can see, the stack is empty. So this would result to a runtime error, or it would result to an exception, okay? And this means that the parenthesis count is less than 0, or there are more right parentheses than left parentheses. As you can see, there is only one left parenthesis and there are 3 right parentheses, but so far what we have encountered is just 2 parentheses, 2 right parentheses and 1 left parenthesis. So this would result to 1 minus 2, that would be -1. Parenthesis count is less than 0, and so the output of the algorithm here is that the arithmetic expression is invalid. You could add something here, some code in here that will be triggered if a runtime error or exception occurs. It will be triggered to output this one, that the arithmetic expression is invalid.